Now look at this.
What's up, about penguins? Today we do topic 7.5 on Hardy-Weinberg equilibrium. So Hardy-Weinberg equilibrium states that if the allele frequency changes, or if the genotypic frequency changes, that means that the population is evolving. There are 5 conditions that must be met in order for evolution not to occur. So if you haven't seen Paul Anderson's 5 Fingers of Evolution, I would highly recommend that you go watch that. So in his video, he gives you 5 ways to remember, or using your 5 fingers to remember. So you want there to be an extremely large population size, because a large population size is going to reduce the ability for genetic drift that we talked about in the last video. You want there to be random mating. There can't be any type of sexual selection. No trait can be more favorable or less favorable in finding a mate. You want there to be no mutations. A mutation is going to add a new allele to the population, which of course changes your allele frequency. You want there to be no gene flow, no individuals moving in or individuals moving out of your population. That will change your allele frequency. And of course, natural selection, okay? We won't want any of the traits to be more favorable or less favorable than the other traits, because of course, that's going to lead to evolution. The Amoeba sisters made this really cute graphic to go with it, so I just wanted to go ahead and share that so y'all could screenshot it if you needed to. So there's 2 equations to know for Hardy-Weinberg. The first equation, P plus Q equals 1. And the second equation, P squared plus 2PQ plus Q squared equals 1. So P is your dominant allele, the frequency of your dominant allele. Q is the frequency of your recessive allele. So if you have 2 Ps, that means you have 2 dominant alleles, homozygous dominant. 2 Qs, homozygous recessive. PQ, heterozygous. So when I teach it, I teach my students to use this chart. And I'm sorry for the graphic being so big, like TikTok was being crazy. So I have a P column, a Q column, P squared, 2PQ, and Q squared. So let's solve a practice problem to figure out how to do this. So I teach my students to do this chart when doing Hardy-Weinberg. So if you're told that you've got 36% of the population is homozygous recessive, that means that you're going to have 0.36 for your Q squared. Now you always want to start with Q squared, 100%. Always start with Q squared. So Q squared is 0.36. To find Q, take the square root. So the square root of 0.36, 0.6. And then I know that P plus Q equals 1. So 1 minus 0.6 is 0.4. To find my P squared, I just square P. So 0.4 squared is going to give me 0.16. And then to find my 2PQ, I multiply 0.4 times 0.6 times 2, which is 0.48. So now, if they give you the number of individuals that are of each different phenotype, you have to count the alleles instead. So you're going to go and say, okay, homozygous dominant times 2 plus heterozygous is going to give you the number of dominant alleles divided by the total, which gives you the frequency of the dominant. And you would do the same thing with homozygous recessive and heterozygous to find the frequency of the recessive allele. Remember, 8 bad pens just says, bye y'all.